hear you.
Perfect. We'll start right away. First of all, thank you so much for attending this webinar, even on a holiday, Ganesh Chaturthi. 3 weeks ago, when we scheduled this, we had no idea. I'm glad that people are able to show up. We'll try and keep this presentation as short as possible so that you can go back to your celebrations right after. So, today we'll be doing the webinar on just understanding magnesium alloys and what all manufacturing possibilities are available in India for you to use magnesium alloys. That's the purview of the webinar today. So on the call, we have with me on my side, I have Mr. Sunil Raj. My name is Anisha Raj, by the way. I'm the director of the organization, and I have with me Mr. Sunil Raj, who's the founder and MD. Also, we have the quality head and the engineering head with us. So if you have any technical questions, we'll answer those for you through the course of the presentation. So just a quick ground rule so that I can set. So all questions have to be asked in the chat box. Whenever you have a question that pops up, just mention it in the chat box. We have a team. We have a couple of members who are accumulating all the questions on the side. So at the end of the presentation, we'll answer all of them at once. Yeah, and if try and restrict your questions only to generic questions which are relevant to everyone. And if there's any industry specific questions, then we'll cover them either via email, or you can also schedule like a callback from our team, and we can do that. Stay muted at all times so that we avoid any background noises. And if there is any technical issue, we'll try and figure out how to go ahead. But in any case, I have like multiple. I have a couple of other options for internet connection if something goes wrong. Right. So the agenda that we'll be covering today is we'll cover what magnesium is, the types of magnesium alloys that are available commercially, why you should consider magnesium alloys. We'll compare magnesium to the other structural materials that are available in the market. We'll let you know the major benefits of magnesium alloy and the major misconceptions that we've heard from customers over the past 25 years. We'll mention a little bit about what prototyping options are available and what production options are available, and designing in magnesium if that's possible or not. And then we'll move to Q&A. So the whole presentation, when we counted last, was about 40 minutes. So we should be done maximum by that time. So nobody needs to panic. We won't do any chemistry test here, but just wanted to let you know where magnesium on the periodic table stands. A lot of customers, when we approach them for the first time, they ask us, what is magnesium? So we thought I'll mention it up front. It's a structural material that is being used abundantly. It's an element which is very abundantly available in the Earth's crust. It is extracted currently through minerals and even through seawater extensively globally, right? It's the third most commonly used structural metal globally, and it's 100% recyclable. Even the waste product that comes out of a lot of the manufacturing can be used in other industries for other purposes. So the current supply chain of magnesium, I'll cover this a little bit. So 90% of supply chain of raw material comes from China. The other reliable countries for magnesium are Germany, United Kingdom, Australia, Israel. There's a lot of options for alternatives, but 90% of complete raw material is currently extracted in China. So they are the major source for this industry. We also in-house, we make our own alloy. So if we use pure magnesium, then we combine it with the other elements to make the commercially viable alloys that are for production. So we do that. We are able to do that within India itself. And India has like abundant reserves of magnesium, but there's no active mines. So hopefully in the next decade, if that does come up, so magnesium prices would definitely drop. Okay, so when people talk about magnesium, they're not really talking about pure magnesium. Magnesium is then alloyed into different alloys, basically, essentially. commercial grade alloys. And when you talk about magnesium, they're usually talking about the commercial grade alloy, and they refer to something. You'll hear something like AZ91, AM60, ZE41. These kind of terminologies would come in when you're talking about magnesium. So just I'll cover the three major series of alloys that are currently available in India, and you would have to deal with if you're getting into magnesium production at any point, or you're interested in magnesium. So and the nomenclature, like how do you recognize what that means, right? So as you can see from this presentation, this is the AZ series, where A stands for the highest alloy content in this alloy, right? So here's on the right side, you will see like a chart, like a list of uh, names of the alloying elements that can be used in magnesium. And you can use that to decipher what A means, what Z means, right? So that's aluminum and zinc. The 9 and the 1 stand for the highest. Nine, the first number stands for the uh, percentage of aluminum, the first element, highest alloy content element. So that's 9% aluminum and 1% zinc. And C stands for the revision series level. So the alloys are constantly revised and the composition is improved constantly. So whenever we are currently at AZ91E, but C is also commercially viable, D is also commercially viable, E is the purest, purest form of that alloy. So that's also viable. But yeah, so that's how you would recognize the alloy names. And F obviously is the temper condition that is there. So AZ series is the most commercially used magnesium alloy in India and globally, and they're used for almost every industry, every use case. You would first consider AZ91 and then you would go to the others usually. The second is the aluminum manganese series, which is the AM series. Now, this is extensively used in automotive and impact critical use cases. So, an example would be helmets, or an example would be steering wheels in cars. These are usually used with the AM series because they have very high damping capability. So, shock absorption, vibration damping, dent resistant. So these are the ones that this series is what is used for those kind of use cases. And it also has very high elongation. So for alloy wheels, probably one more use case that you can see. The third major series that are used in aluminum, in magnesium globally, are the ZE series, which is the rare earth series. So ZE is zinc, and E stands for rare earth. Now these are the reason that this is the reason this alloy is majorly used is because other alloys of magnesium have lower creep resistance, right? So at elevated temperature, they're not great, they're not great materials to be used for engine use cases and things like that. So the ZE series or the rare earth series, there are a bunch of rare earth alloys now, which are used specifically for auto engines, aerospace use cases, which would be subjected to elevated temperature and need to maintain a certain amount of strength even at that elevated temperature. So anywhere between 200 and 350 degrees, also you would get great strength from these alloys. Right. So we'll quickly move to the advantages of magnesium alloys. I'm sure you must have heard, even with basic research, that magnesium, the main use case of magnesium is lightweighting, right? The reason lightweighting is important, why? Because the density of magnesium is significantly lower. It is 33% lighter than aluminum and almost 75% lighter than steel. So that's one of the major primary use cases why people usually consider magnesium. The second major property that customers are interested in is the high damping and shock damping capability of magnesium. So not only will it prevent damage to the equipment on drop, when it drops to the floor or during a crash. It basically it's used in almost every vibration damping equipment. Uh, I think someone needs to mute themselves. If anybody mute yourself. Okay. Sure. The third is strength to weight ratio. So even at very thin walls, you'll get very high stiffness with magnesium. So aluminum usually is recommended to have 1.5 or 2 thickness, wall thickness. But whereas magnesium can be cast as low as 0.65. We've done 0.65 wall thicknesses, and even at that, you get significantly good strength or stiffness, which is required for the use case. Obviously, EMI shielding is an important secondary property that our customers require for electronic use cases. And a very interesting use case for magnesium comes with corrosion. So magnesium is both can be made corrosive or non-corrosive on demand. Currently, there are vendors like there are coating vendors that guarantee like lifetime warranty on non-corrosion with magnesium specifically. And there are some use cases where you would want to make magnesium more corrosive by adding a few elements, like adding a few elements which will help the composition like corrode faster. So this would be relevant when you're looking at use cases like oil and gas, or whether you're looking at use cases where like say orthopedic micro screws which you can put in your body. So in these use cases, you would want the magnesium to corrode faster, or in the environment that it's there. So that can be created with magnesium, which is a very niche use case, which a lot of people are trying today. Nowadays, we're getting a lot of requests for those. The last one, just like aluminum, it has high electrical and thermal conductivity, which is required for most customers. Why do our customers? I thought I'll cover quickly why our customers. We've seen our customers approach us. So most of them are looking at meeting the industry customer demand trend. So, say example, they see that tablets are going down and customers are demanding lighter tablets. They approach us while considering magnesium as the enclosure, right? Or say they see a rugged laptop manufacturer. The second one is comparative advantage, where say a rugged laptop manufacturer sees that their competitor's laptop is way lighter, and they would want to meet that, or they would want to be that first player who is making lighter rugged laptops, right? So as a comparative advantage, they approach us. The third is where industrial equipment, they see that if there's a moving component in an industrial equipment that is subject to wear and tear and energy consumption, in such kind of cases, a lot of machinery we provided heavy components which are made out of magnesium to reduce the energy cost, and also to improve wear and tear and things like that. So, and the final is something like a drone sector. Compliance and standards are more like related to whenever there's emission standards, or say when there's weight limitations set by the industry. This would be relevant. I think, I don't know whether it's still relevant, but in drone sector, they used to be like guidelines as to the lighter, like I think compliance and approvals are easier for drones when they're lighter. So under a certain weight limit. So lightweighting becomes a priority at that point. Okay, so we'll try and compare magnesium to the other lightweighting materials that are currently being used in the market. So we'll look at steel as the baseline, and then we can convert, like we can look at all the others as options, right? So we have AHSS, we have aluminum alloys, magnesium alloys, titanium, glass fiber, and carbon fiber. So if you look at the chart in terms of emission reduction, you would see that magnesium offers the highest. Magnesium and carbon fiber, obviously, but magnesium definitely offers the highest in terms of price point. Magnesium offers the highest emission reduction, and also the highest uh, weight saving in comparison to steel. And when you look at the third column, which talks about the cost, we are like there are a lot of use cases. A lot of people come to us when they're trying to convert a steel component into a magnesium component. While we have to increase thicknesses to maintain strength, we are able to, in most cases, able to meet the cost. Depending on it all depends on the component, obviously, but in a lot of cases, we are able to meet the cost when there's a conversion from steel to magnesium. And when you look at aluminum, we are able to either, in some cases we are able to meet the aluminum price point itself, or in some cases we are slightly higher than aluminum. So this is during transition from aluminum to magnesium. So yeah, I just thought I'll quickly show you this slide. I'll keep it here for another 10 seconds. Yeah. Okay. So another way of comparing these materials, we've looked at three different materials: aluminum, A380, AZ91, and carbon fiber, and we wanted to compare them on different parameters. So you would see that there's a lot of these. So just so that you understand, 1, 2, and 3 in this slide means the ranking, which one is the best amongst the three. And you would see that uh, carbon fiber and magnesium would have the maximum number of ones. But where is magnesium better is essentially in terms of the density. When you look at ability to cast in thin walls, the least amount of draft during production, you're looking at electromagnetic shielding, you're looking at machinability, you're looking at recyclability, die life, the die life that is you can get that's definitely one more, and the processing time that it takes during this is in context of die casting. So I'll just stay on the slide for about 10 seconds so that you can go through it. Yeah. All right. So the three big benefits, I'll reiterate them so that you're clearer, and I'll give you examples for each. So the first one being lightweighting and weight to strength ratio, right? So three major examples, like I mentioned, 33% lighter than aluminum, 75% lighter than steel, and three examples that I'll give you about from industry is like if you look at the Boeing 767, it saved 37,000 liters of fuel per year for every kg of magnesium it replaced with aluminum components. So that's a major cost saving that is possible uh, through something like that, right? Right. So that's one way that we've looked at how lightweighting is being used by different customers. If you look at, even if you just go back and go Google the top 5 laptops of last year, and just look at take the name of the laptop, go and check what body that has, right? What chassis is it made out of? And inevitably you'll see majority of them are made out of magnesium chassis, and that's a trend globally that you would see, that globally best selling laptops are currently starting to be made out of magnesium alloys. So that's something that I believe that will also customers will start demanding in India itself, and we've seen that happening already with a few consumer electronic companies that we work with. And the last lightweighting use case I'll tell you is about the wheel rim. So currently the standard in India is the aluminum wheel rim, but globally magnesium wheel rim is the go-to alloy wheel, and it offers anywhere between 5 to 7% increase in mileage, 4% plus improvement in braking and acceleration, and also offers a longer life for suspension, brake components, things like that. This is like another lightweighting use case that automotive has figured out. Damping, I'll give you three quick examples. When you look at vibration testing equipment, this is usually when you're making an electronics product or any product, you want to do a vibration testing for your component. Every vibration testing machine itself is made out of, majority of the components in that would be made out of magnesium, for the same reason that it offers significantly improved controllability, reduction in resonance amplification, and the test results are significantly more reliable and accurate. So vibration testing equipment itself, like armatures, fixtures, slip tables of these equipment is made out of that for its damping capability, right? So we almost every vibration testing machinery company in India takes some component or the other from us in magnesium already. When you look at laptops and rugged laptops, one of the major places where damping plays a role is protection of internal electronics. So you're trying to make your laptop as you know, drop resistant, shock resistant as possible, so that there's no damage to internal electronics even during a drop, right? uh, it's and The difference in damping when you look at aluminum and magnesium is of almost, there are alloys that offer, like most alloys would offer anywhere between 30 times to 100 times better damping than aluminum. So that's something you should consider. Magnesium wheel, sorry, this is incorrect. Steering wheels, if you look at steering wheels in every car, Indian car as well, at this point it's a safety standard that every Indian car has to have a magnesium steering wheel, because during a crash, when the driver falls onto the steering wheel, you don't want their chest to be crushed by the impact, but basically you want the material to be to protect the driver and basically absorb the shock that comes from it. So that's become like a safety standard nationally and internationally for a magnesium use case. And third, EMI EMC. So magnesium offers the best wall thickness to shielding ratio. If you look at medical equipment, they have standards in terms of to how they want to control radiation and maintain standard, maintain the EMI EMC shielding. So that's why magnesium is like a globally go-to material in medical devices globally. Uh, when you look at any IoT product or any, like say even a drone, there's extensive what do you say, radio frequency interference. There's all of that. So which is where magnesium offers a uh, very good solution there, right? And for the past 25 years, we've been working with DRDO and ISRO labs, where we've been making enclosures for them, and EMI EMC being a secondary property requirement in all of that. Okay, the four misconceptions that people would talk about, and I hear almost, I have to address this with almost every customer. Um, is One is about the cost. They believe that it's too expensive. They believe that magnesium corrodes too easily. They believe that it burns easily or is a fire hazard, or the creep resistance. That's the four major ones. If you look at cost, I'll cover cost in four elements. One is the raw material cost comparison. So even though in this chart you will see that magnesium is slightly higher than aluminum and zinc, the reason I've chosen magnesium, aluminum, zinc, these are the three die casting alloys. So uh, structural component die casting alloys. So I thought there'll be a good comparison. At the bottom, you will see like a rate of casting as well. And you'll see there's a major overlap between all three, right? For sure, magnesium will be slightly more expensive at the die casting rate as well. But if you look at the raw material cost comparison, you'll see they're fairly close, even though magnesium is slightly higher. If you look at the past decade of raw material cost fluctuation, you will see that magnesium is the most stable. Relatively, it has stayed stable and at the same price for the past 10 years, and it has not changed significantly. Whereas you'll see major fluctuations in aluminum and zinc. So that's one aspect. In terms of production, uh, if you take 1 kilo, there's a part with 1 kilo of magnesium, you are able to make three parts. What that density difference really means is that with aluminum you are making about only two parts, and with zinc you are making less than a part, right? So that's just how much better raw material can be used. Whereas the same raw material that is bought for hire, but there's cost saving that happens during production in that way. The third major advantage in terms of cost you will get, and this is more in terms of die casting, is that magnesium uh, does not have any affinity to steel, hot die steel, and they are able to offer at least 2x or even 4x the amount of die life that aluminum offers for die cast. So on an average, we promise customers double the die life than they would have got with aluminum, and that'll be almost 100% true every time. And that itself, if you are a part of an industry which requires high volumes of components being produced, and which go higher than say 1 lakh components of the same component, then there directly you save almost like 10 lakhs. In this case, let's assume that the die costed about 20 lakhs, which is like a reasonable price for like a large component. You'd say easily about 10 lakhs right there. Right. The final part in terms of cost, I will cover in terms of stiffness. So this is if a 1 kilo of metal is used in magnesium to create equal stiffness. This is the weight of the components at equal stiffness. So say something that would give you equal stiffness in magnesium in 1 kilo, you would require 1.8 kilos in aluminum, and you need 2.1 kilos in steel. So that's also one place that in terms of reducing wall thicknesses, and in that way you could also save raw material and price. So all these methods we've mastered over the past 25 years, and we help customers whenever they are open minded enough to approach us for transitioning to magnesium. That's something we help them with. So right. In terms of corrosion, someone had a question about corrosion just now in the chat box a while back. So this is just a presentation, like this is a study that was conducted, so 10-day salt spray test conducted as per ASTM B117. This is not conducted by us, this is by a third party, and you would see that magnesium AZ91D has the lowest corrosion level in comparison to the other two options that are available, right? So this is one reason why. The reason I'm mentioning it is because a lot of the understanding of magnesium comes from older data about magnesium, the capability of magnesium alloys. Whereas with the revision of the series of the alloys, the more purity we were able to create. Like say, if you iron, nickel, there are components in alloys which create that corrosion effect in magnesium. And when you remove those out of magnesium, they no longer are corrosive. So now there's mastery in people understand how to remove those corrosive elements from that magnesium alloy and give you better corrosion resistance. And the second one I also mentioned about corrosion is that now in terms of coatings have become so good that now there are companies that offer like lifetime warranty on coating for magnesium that we work with. One example being indestructible paints. That's one that gives a lifetime warranty. Uh, Another one is the third one. Obviously, I would like to mention is obviously you have to design as per to avoid as in terms of galvanic corrosion, to avoid that. There will be some design allowances and design changes that would be required, but nothing too major, right? The third major myth that we hear a lot about is the fire hazard. So one thing you should know is that magnesium is only dangerous when it's in its molten state, and it's when it's in powder state. Powder state, you would know, it's used in crackers. So that's majorly a powder form that is created and that you're lighting. When you look at molten state, when it even comes in contact with moisture, it explodes. It has an exothermic reaction. So there's high technical skill and know-how that is involved. Over the past maybe 3-4 decades, people have seen a lot of magnesium fires in magnesium foundries itself, and that's usually, when you investigate that, it's usually a lack of process and standards being maintained in terms of magnesium melting, or something silly being done essentially. The second thing about fire hazard, people are concerned that okay, if I just buy a roll plate and just machine it, will it catch fire? So yes, like when you are creating the machine scrapes, it is important that you clear out the complete bed from magnesium, any form of magnesium powder or any form of magnesium scrapings that have been created, the turnings and the chips that have been created. So that have to be cleared out of the bed, and they have to be kept away from the machine, because there have been incidents of people not maintaining basic standards of safety when dealing with magnesium in machining standards as well. And there have been fires that have happened in India itself with this. But most of our customers, there are a bunch of customers ranging from defense to private companies which take roll plate from us, and we are able to help them with the basic precautions that they need to maintain. And we've so far, touch wood, we've never had a incident with any of our customers whom we've helped with magnesium so far. So we'll be able to help you as well. No challenge there. Yeah. So fire hazard. One last thing I would like to mention is that uh, if there is a history of tampering in your product range, for example, Volkswagen used when it introduced the engine, the magnesium engine in 70s. There was a like there was a not a standard, but basically there's a practice of tampering with the engines to modify them in the UK. And you would see that over a period of time, when people try to tamper with the engine and try to weld it and try to modify it in different ways, there would be fire accidents that would happen. So that's one thing that's not something that I can guarantee you about. You have to understand your product and see whether there's any use case where tampering would happen, and there you can consider that something like this you should be careful of. Right. So manufacturing possibilities we'll cover. So just like aluminum, magnesium is available in cast blocks. This is both forged blocks and cast blocks. Then we have billets, we have forged blocks, we have roll plates and ingots. These are the forms that are usually available in the market, same as what you would find in with aluminum as well. These are all the various processes that we have done for magnesium so far, and we are capable of doing in-house and is available in India if you require. High pressure die casting, obviously for high volume production. There's for lower like gravity castings like sand and permanent mold, which are for relatively lower volumes. We also have centrifugal castings. We also do machine parts. You can take like a forge block or a roll plate and then you can machine it out. You can do extrusions. So we are the only company in India which can do extrusions of magnesium. Roll plates. We are able to make roll plates in India itself, so to reduce the cost of raw material. Forging and also sheet bending. So that's all the processes that we've been able to establish over the period of time. We are also currently working on investment casting. We are also working on closed die forging. This is the forging that I mentioned here is hammer forging or just making blocks, right? We can also do closed die forging. That is something that we are currently working on. These two projects, investment casting and closed die forging. So we will be probably within the next quarter, we'll have a process defined and with all necessary quality standards to give you repeatably high quality product in that. So early stage prototyping, the three major ones that we would offer or are available are mentioned here. So at the top is the name, and at the bottom you'll see the sizes or the MOQ that are relevant for low volume production. In sand casting, anywhere between 250 grams to 1 ton also we've done. When it comes to extrusions, we've done as low as 10 kilos, uh, 10 kilos as well for extrusions. And when it comes to machining, these are usually the options that are available for aluminum as well. Aluminum as well. When I mentioned machining, this is machining it out of rolled plate and forged blocks. So that's what I mean by that. Okay. In terms of production, uh, there are more processes that we have done, like I mentioned, but most of our customers, when it comes to magnesium, they usually fit these three options. High pressure die casting, which is anywhere between 50 grams to 7.5 kilos, anywhere in that size, and you want it in bulk volume higher than 1000 or 2000 parts, we are able to offer that for you. Extrusions at bulk volume, if you want the cheapest rate possible, then you need at least 300 kilos. And permanent mold castings, Yeah. So permanent mold casting, so like 50 grams to 150 kgs. So yeah. So permanent mold would be anywhere between, would be a good option if you're looking at anywhere higher than 100 and under 1000. That's when I would recommend permanent mold casting to you. So yeah. So the last part is about design. I wanted to mention what in terms of design usually we've seen from through customers. So usually a lot of customers come to us when they want to redesign a part, right? They want to redesign it from steel to magnesium or something like that, some other material to magnesium, and that is possible. We have in-house resources that can help you do that. The second is they come to us and they say that we want to optimize this for weight. It's probably made in aluminum or whatever, and if there's any further topology optimization or anything else that we can do to reduce the weight, we can do that for you. So that's another major thing that we customers come to us for, and it's possible, not just with me but anywhere outside as well. People would be able to help you with this. Custom designs, if you want something custom designed to your magnesium needs. uh, for example, a lot of customers come to us currently for designing of IP67, IP68 enclosures in magnesium, aluminum, a lot of different materials. So that's where we step in, right? We step in and we do uh, we design that completely from scratch depending on the dimension and the requirements, and we deliver that to customers. And every form of analysis, everything from vibration analysis, or if you need FEA, all of that can be done uh, with us internally, right? If there's any reason why you want to, if you have a specific question related to your industry, you can always email us at this email ID, which is sales@exclusivemagnesium.com. We respond as quickly as possible usually. uh, right, so you can always email us there. If there is a component that that you believe is worth considering for magnesium, or you would want to understand it whether it makes sense manufacturing wise in magnesium or not, you can always send us like a performance critical component, and we'll give you like a budgetary estimate and uh, tell you the manufacturing feasibility of that component. That's obviously at no cost, and we encourage it. Even if you're not if you're just exploring it, we are very open minded. You can just send us the drawing and we'll help you with understanding whether it makes sense in magnesium or not, with no commitments as such. And the third would be, if you want to schedule a discussion or a meeting to discuss like your industry and your product priorities, and if magnesium makes sense at all for you or not, then always we are available for a call. I'm just gonna go to the next slide where you'll see my number. Just a bunch of customers that we work with, just a few. If you go to our website, you'll see a few more, but we work with over hundreds of customers over the past 25 years. So here on the second, over here you would see my mobile number. You can reach out to me directly. I'm available. My email ID is also mentioned right here. So always available to help anyone who's interested in exploring magnesium, even in a very, very small way, even in an experimental way, even for R&D. Anything you require in terms of magnesium in India, think of us and we'll help you. There's no challenge there. Okay. If right after this presentation, if don't be concerned about um, your questions if they were not answered. Uh, I would say what we would do right after this is we will send you the presentation. Send you the recording of this webinar. We will also send you an FAQ document which has answers to every question that has been noted over here. So we'll make a note of all the questions that are being asked over here, and if there's any further questions right after the webinar, if someone sends us, we'll answer all of those, mention it in an FAQ document, and we'll share it with the recording itself so that you have no problem, right? So, right, I'll go back to the slide. I'll leave it here. If you need anything, then please feel free to reach out to us, and we'll help you with however we can. right? You can like, thank you so much for attending. Happy Ganesh Chaturthi to everyone. We'll stay on mute, and if you whenever you're ready, you can leave the call. Good day, good weekend. Thank you very much.